the idea of power. You guys remember what power is? Go back and look at Unit 3 toolbox. What was power? In Unit 3, we said power was W over T. What the heck does that stand for?
Weight, energy.
Yeah, it's the work you do divided by the time it takes you to do the work. And we said that work, another word for work is just energy transferred, right? The energy transferred. Divided by the time, or the rate that energy is transferred. So if you can do 1,000 joules of work, and you can do it in 10 seconds, then you're doing 100 joules every second, right? And we measured the energy transfer rate in watts. So is that vaguely familiar, guys? So the units we used were watts. A watt is a joule per second. So 100 watts means you're transferring 100 joules every second, right? Well, heat is just energy. So we can talk about power in the context of heat. All right? So here's what we would do if this wasn't COVID and we weren't stuck in our seats not touching lab equipment. We would take the microwave back there. We'd take a cup of water. We'd put the water, we'd take the temperature of the water. We'd stick it in the microwave. We would warm it up for 30 seconds. We'd take it out and we'd measure the temperature again. And what would happen to the temperature of the water? It'd go up, right? So let's just say, for the sake of argument, that I take a glass of water and the mass is 0.25 kilograms. And let's say that the initial temperature is 16 degrees Celsius, because that's the temperature of my water in my faucet. I microwave it for 30 seconds, and the temperature turns out to be 49 degrees Celsius. And that's what happens when I microwave it for 30 seconds. Can you guys calculate the power of my microwave? Could you figure out how powerful my microwave is? At what rate it is transferring energy? Well, you got to find out how much energy it transferred, right? So, in the context of thermal physics, the power, it's still the energy transferred. But what do we call the energy transferred in this unit? We call it Q. It's still the energy transferred. It's just a different form. So power is still the energy transferred divided by the time. And how do we find Q? How much heat does it take? Well, that's MC delta T. So if we want to find the power of the microwave, grab your calculators. Take the mass of the water, 0.25, times the heat capacity of the water, 4,186, times the change in the temperature. So use parentheses and put 49 minus 16 and close your parentheses. When you do that, what do you get for Q? Anybody get it there? Garrett, what'd you get? 1,151. Gotta be bigger than that. Maggie, what'd you get? 34,500. Is that a good ballpark? Yeah. You see the mistake there, Garrett? That's how much energy was transferred, joules. And how long did it take? 30 seconds. So how much energy was it transferring every second? Was that what you were doing?
That's what I was doing.
So what is it?
I got 1,151.50.
Okay, 1,150 I'm going to go with. Joules per second, or watts. My microwave transfers energy at about 1,150 joules per second, or watts. So this is just a review, okay? We're gonna solve some problems with this. You don't need to show your work, just grab your computer, find problem set 7.4. We're gonna be finished in 15 minutes, all of us. When we're finished, we're all gonna have a cup of hot chocolate, because in the original lab, we've got a big huge urn back there, and we would calculate its power too. But we'll still have the hot chocolate part though. So when you finish, you get a cup of hot chocolate to sip while you do the rest of your problems, whatever else you need to do. So everybody go to problem set 7.4 right now. We're gonna solve problems with this idea that power is the energy transfer divided by the time. Okay?